This is a product examination project based on a commercial scooter. As shown, there are various components in a scooter. However, we'll be discussing the four listed. The scooter's wheels are made up of two parts, a tire and a rim. In this case, the scooter's rims are made up of plastic. Parting lines show that it was probably injection molded by a two-piece mold coming in vertically on both faces of the wheel. The scooter's tires are not hollow, which indicate that they are made out of polyurethane. After the rim is injection molded, its outer surface is sprayed with an adhesive such as glue so the tire can stick to it properly. The advantages of this manufacturing process are that it can be mass-produced for a low cost at around $13 a piece. Alternatives to this would be an air-filled tire or a metal rim. An air-filled tire would be susceptible to pop, however it would be ideal for off-roading, and a metal rim would have increased durability but it would have higher costs.
The second component we chose was the kickstand / quick release lever. The process we believe was likely used was powder metallurgy. We believe PM was used because PM does well with small and precise parts. When new, these components were smooth, and when you look closely, it looks like there's small pores from possible sintering. The advantages of PM are it does well with mass production of smaller parts, it leads to low waste and lower costs, it's pressed to final size so no finishing process is required at the end, and it leads to accurate and precise parts. Alternatives can be CNC. CNC is more cost effective for small production runs, but scooters are produced and sold year round. There's also die casting plus machining. Die casting can be used for the main component and machining for the finishing process, such as holes and grooves, but that will require two processes instead of one.
And for the component 3, the T-bar, the process likely used was rolling, machining, and welding. The material is aluminum, and the advantages of it are the good elongation, elasticity, and it is also very lightweight. Alternative materials would be steel, which is cheaper but it will be also heavier, and the chromoly 4130, which is expensive, but it has great strength to weight ratio. The process that would be alternative would be in machining, CNC, which would make it more precise and efficient, but it would be also more expensive.
The next component I'm going to talk about is the bricks. The manufacturing process likely used here is sheet metal stamping using aluminum. The advantages are low labor cost, high production volume, and a simple and easy design, which is relatively strong and reliable. The alternatives would be to use a rotor and caliper system, which would yield better stopping performance, but at the cost of redesigning the back end of the scooter, and also the extra parts would add cost and complexity to the scooter. That's all, and thank you for your time.